Examining distributions. In this program, we'll learn basic descriptive statistical methods for examining the distribution of a quantitative variable and the distribution of a categorical variable. It's important to note that we have different methods when the data we're working with are quantitative or categorical. When working with quantitative data, we'll want to learn how to examine the distribution in terms of its shape. Here we're looking for two basic answers. Either the distribution is described as approximately normal, or we describe the distribution shape as decidedly skewed. We'll also learn to obtain and report the mean and standard deviation. Visually, we'll use the histogram for reporting, but we'll also learn to use the normal quantile, or simply NQ plot, to assess how close the distribution is to a normal distribution. And that's going to help us with our outlier screening. To begin, we'll go to our Unit1.xlsx workbook, which has been pre-populated with our Case 1 data. We're going to start with the variable income. Income is in thousands of dollars, and it is a quantitative variable. To use this Excel tool to do our descriptive statistical analysis of income, we're going to tell the Excel tool what variable to use first. So for a quantitative variable, such as variable number 1, we would input variable number 1 here on the data sheet. Clicking the Worksheet tab Histogram shows me my histogram and my frequency distribution table. We could see that the mean income is $129,325, and the standard deviation is $44,368. Our sample size is 77 cardholders. Is the distribution approximately normal, or is it decidedly skewed? A normal distribution would be about bell-shaped. We would see a peak in the center and fewer data as we move out from the center. It appears that this distribution is approximately normal. Clicking the Worksheet tab, NQ, and Box, we can see the NQ plot and the box plot. The NQ plot appears to follow an approximately normal distribution. We see the cluster of data in the middle and fewer as we move out toward the upper and lower tail areas. The box plot also shows us a fair amount of symmetry supporting our belief that the distribution is approximately normal. So here we would say that the distribution is approximately normal with a mean and standard deviation as we reported. N equals 77, and we could simply copy this histogram and paste it into our report. Finally, we'll want to screen the data for any outliers. Because our data fit a normal distribution fairly well, we could simply look to see if any of the individual data have z-scores beyond 3, either positive or negative. The z-score tells me the number of standard deviations a data value is from the mean. For example, the income of $93,000 has a z-score of negative 0.82. That's less than 1 standard deviation from the mean, and therefore it's about average. An outlier would be an income that's either more than 3 standard deviations above the mean or below the mean. And the zeros tell us that our distribution is outlier free. So why do we examine the distribution of our sample data, such as incomes? Well, it's important to understand that we are working with one sample of data, but eventually we're going to want to use this one sample of data to make an inference or a guess about an entire population. Understanding the distribution in our sample helps us do that effectively, because some of our methods will require a normal distribution or at least something close to it. Also, outliers or extreme values in our distribution can affect the mean and the standard deviation. These statistics are the foundation of, say, our inference for the population mean. So it's important to understand the effect that any outliers, if any, have on those important statistics. Moving on to categorical data, we'll use the Unit 1 Excel tool to learn how to create a frequency distribution table, a bar graph and pie chart, how to adapt our Unit 1 tool to make what's called a Pareto chart, and then finally how to basically interpret our information. So back at our Unit 1 Excel tool, we're working with the case data. Here we have two categorical variables. Gender has two categories, M and F. Ed level has three categories, master's, bachelor's, and D for doctorate. We're going to work with the two category variable gender. We can see that gender is variable 4. So to make our Excel tool do the analysis, we have to tell it to use variable number 4. And for categorical data, we have to also specify the category labels. Here we have two, M and F. Then simply click on the Worksheet tab Categorical to get our results. First, our frequency distribution table shows us that 31 of our 77 sampled cardholders are men and 46 are women. This is a gender split of 60-40. The bar graph shows us the specific frequencies, and the pie chart shows us the percent distribution. If I wanted to change my bar graph to a Pareto chart, I could go back to the data sheet and simply reverse the order that the categories appear on my chart. Now I have a Pareto chart, which is simply a bar graph in descending order of frequency. So when we do this descriptive analysis for categorical data, what are we looking for? Why do we do it? Well, descriptively, we're looking for key insights in the data. If the demographics of a market, for example, is skewed toward one particular category or another, that's going to affect things like the way we market and advertise. Also, if there's something anomalous in the distribution, such as a very low frequency in a particular category, we might want to note that and eliminate that from our sample. All of the understanding of our sample data is going to help us make better decisions with the data. Remember, our samples are going to be the basis for the statistical guesses that we make about the entire population. So the more we understand our raw data in the sample, the better we are going to do making guesses or inferences about the entire population. This concludes the Unit 1 program, Examining Distributions. The next program in our sequence is called Examining Relationships.